Hi guys, we're going to go through the process of mixing up the geopolymer anode material and then injecting it within the masonry mortar beds. I'll do the mixing of the product, the appropriate dust masks. Everyone's got glasses and gloves. Health and safety, there's an eye wash station if there's any mishaps. You get any on your skin, just wash your hands clean. So I'll get this powder out.
So it's been pre-weighed,
Yeah, it's all been pre-weighed, pre-packaged. So it's just as simple as adding part A and part B, mix it, it's the required consistency. We'll then put it into the mortar pointing gun. Right. We'll mix it for a couple of minutes, make sure it's well amalgamated together. I'm going to get my dust mask.
You can't top my arm. I will. Just warning, it's a highly alkaline material. This is alkaline activated. So if you do feel anything on the skin whatsoever, it's important to go wash straight away. It's highly alkaline. Basically, there's two components. The powder is a blend of all those recycled materials that I mentioned in the presentation. And the liquid is also alkaline, but less so. It's a silicate solution. So you can see it's starting to bubble and react.
So the powder is the more corrosive of the two?
It is. But what's particularly alkaline is a mix of the two. So it has to go through that alkaline activation in order for the material to start to go through the hardening process. So as I mentioned in the presentation, it's not a hydration reaction, it's a polycondensation reaction.
Yeah.
And that creates that amorphous inorganic polymerization. So the reaction keeps going. What we find with compressive strength data for the concrete version of this is it will still keep increasing compressive strength even after 120 days. It's still reacting, but it is in hardened form.
You get them any colour you want?
You can add colour to it. You can add coloured aggregates to it. Have a different finish. So this particular version is obviously simply for the bed joints, so any of those features are important.
What's your work time on the other thing?
You have about an hour or so. You know, you can rework it, you can remix it, it'll go fluid again. It's very purely material. But once it really starts the hardening process, the polymerization, then you've not got much time left. You've got about an hour to mix it.
So adding color like a colored aggregate doesn't affect its performance at all?
Nope.
Its conductivity?
No, we add any sort of aggregate, and obviously the compressive strength are measured on cubes normally. I think you just showing it over here. But typically in the concrete we're finding 50-60 megapascal. Here we've got a little less of the silicate solution in, so we're down to about 20 megapascal. It's softer.
Could you adjust the compressive strength if you wanted to?
You can tailor it according to what components you put in the mix.
Right, so say you're pointing back to like terracotta, a really soft material.
Yeah.
You want to
It's
reduce
very important that you want to reduce it, even down less than 20.
Yeah.
So in the other pail, they would just water. So it would just wash off immediately with the water on the tools.
Salt water cleanup?
Yeah.
Is that a branded product by Sika?
Yes.
You guys manufacture it?
Yeah, we manufacture the powders in the north of England. And we call it a plus point anode. So plus was the anode connection, and it's a pointing anode, so it makes sense. Plus point on the bottom. I like it. My cheesy trademark.
Spend more time on the signs than the names of it, obviously.
So as you can see, it's a very workable and gunnable material. So using the mortar pointing gun, it does go in very, very easily and very quick. Speedy processors, as you'll see in a moment.
Who's going to be first? Have a go to the left?
Good question. Actually,
I learned in my basement shower remodel how hard it Oh man. Can you imagine doing it for 8 hours straight? Like your guys doing high rises?
You get good at it eventually.
Oh yeah, I tell you. And you get forearms like Popeye too.
Yeah.
In this space here.
Sure. Yeah.
The other one was done yesterday for power up, so
Okay. And just do like a couple of joints.
a couple of times,
And you really just fill it out to maybe a hand out.
say they go sideways, kind of looking to put but not much in and leave the rest to finish the point.
The point back. Yeah. Okay. So maybe just a 1/4 inch deep. They'll allow that for the mortar, the finished mortar. All right. Shoot. I probably should have watched Robert do this first. So
Well, I can do a little bit of a demonstration. If you can see, it's probably a good example if you're just looking at this point. It does
If you look above here, you see it.
flow
okay. Yeah.
very well. And it is as simple as squirting the geopolymer
Just like using
into the
just
bed
like
joint,
caulking, right?
just like caulking.
Kind of thing. I can feel it warm in the gun.
Yeah, it's quite warm. That's it, do the perfect. And the idea behind leaving it shy of the front face is so you can repoint with a colour match mortar where necessary,
Right.
and no one will ever know it's there.
Okay. Makes sense. Do you tool it afterward then?
You can tool it afterwards. It's best to leave it a few minutes to stiffen up,
Yeah.
and then you get a better finish on your.
Makes sense.
I would add, the one we prepared yesterday, we have a titanium wire attached so we slot the anode wire in to feed the current and then point at the wire.
So the warmth, is that the reactivity in the gun?
Yeah,
Okay.
Yeah.
Just like an epoxy.
Nice for winter time.
Yeah, right. Keep you warm.
Yep, and you can use it down to -15 as well.
Oh yeah. What is that, Fahrenheit?
Celsius.
Oh, nice.
That's in Celsius, yeah.
It's very flowable.
Yeah, for sure. It's similar to caulking.
Yeah, it couldn't be easier really. It's a very, very easy technique and works a dream.
So when the masons are done pointing, usually the cleaning process for the face of the brick, can you just wire brush that off there?
Yep, that's exactly the same method.
Okay.
You can sponge it down as you go, and then
So that's the actual wire. It's just as thick as
any parts that are a bit more stubborn, obviously a little bit of a wire brush.
Right.
Yeah, that's tight.
It might be time to reload the gun. Yep.
Some of these joints are not as wide as the brick joint.
Yeah. So, I mean, these are larger joints.
Any information you want to tell me?
Yeah, so basically each time we reload the gun. We'll give it a quick clean out. Make sure there's no debris in there. And then it's ready to go again. Very simple process. Not technical at all.
How long is the working time on this stuff?
The working time for this material is anything up to an hour. This particular mix should last around about 45 minutes. So before I fill the gun again, I'll just remix the material and it makes it flow a little bit better.
I mean, you can play with the liquid content. So this one's stiff. What we don't have on because of the snafu, we have the liquid. So we put a little less in this one.
We have some pointing tools over here if you'd like.
Let me just flatten this out. Yeah, it's already firming up. That's probably perfect though, right there. For tooling
As
it.
Rob said, if you just leave it a few minutes just to start stiffening, and then you can finish off by pushing it in.
That's another reason why it is important to clean the cartridge gun out. Just going to check this.
It's actually easier than mortar as far as toolability.
Good.
Yeah. Which way can we good to go?
You see that nice and light for the camera?
Would anyone else like a go?
Okay. We're trying to get a picture.
Yep. Careful you don't get it on your jacket.
Alright, Eric's going to take our picture.
You get a lot of people.
Is it set up like a mortar, or is it more flexible?
You can. This section was done yesterday, so you can give it a prod and.
You try and scrape on it.
Yeah, it gets pretty firm.
Yeah, it's almost like a plastic.
Yeah.
Or is it that cable there? It's no different from pointing a regular mortar. So, nice and easy.
Tony said it's easier.
It's easier than a regular mortar.
So it should be cheaper.
Yeah.
I wouldn't say that.
Would anyone else like a try? Is everyone happy?
We're good. Thank you.
Very simple methods.
Sure.
So the next step is we can show you a power up of the system that I installed yesterday. So it's a mini cathodic protection system. We'll take some base readings and then we'll switch the system on and take some on potentials at that point. If you'd just like to give me a second to clean this gun out.
The wire is already in. You already have the wire in.
Yeah, we did this space and did the wire.
Oh, you guys did it.
So we've got one face for everybody just to feel the product.
Yeah.
This one, well, we'll show
It's got pretty good coverage.
I would say probably we have to load it 2 times to finish an area like this.
Yeah.
How it holds it
If
where all the rubble is right around.
if you want to repoint just straight off the
wall,
board, you let it set up a little bit,
you know, whatever paper.
then take it, you point some trowel, you do regular pointing.
What's the rule? So when you go on,
Apparently it still works as long as you have.
you know, when you got the big
touching the
beam going up and down, how far this way do they have to be spread?
Well, there is what I mentioned in the presentation was about a throwing power
Right.
of the anode. So it will dissipate with distance. So we've got it all along that line there, but really we're just trying to protect that steel. So we probably stop this little brick course.
But as far as
Just
going
in that
up or
line.
down,
But you need to put it in all the bed lines.
oh, in each of those? Yeah.
So now we're going to record some base potentials on various points around the mock-up. We've got some record sheets. Graham's just getting them now.
Write down the numbers while Rob shouts them out, and you can see the record of
So just
performance for
do
the second group.
the top box. First point, R1, R2, R3, R4.
Okay, so it'll be 1, 2, 3, 4 like
Yeah,
that.
correct.
So your base readings and then the on values should be good. Base values and on.
Okay.
So we have an R1 value of minus 21. An R2 value of minus 23.
Do you want me to read it?
Scratch that, we had a loose connection. But yeah, both. Just go to the next template down. Yeah. So I've got a loose
Do you want me
connection.
to hold it together?
It's the crocodile clip. Apologies for that. Or is it that cable there?
Not gonna move.
I have no idea. No, it should be good enough to take.
That's what we got.
Yeah. So we're minus 37 for R1. Minus 23 for R2.
Was right.
It's the same as well.
Yeah, it was.
Yeah.
Plus 10, plus 9.
Yeah, plus 10.
It's tried out massively.
And for location number 4, minus 50. So we'll turn the system on. It's going to be, I'll read the voltage out first, and then the amps. So that's 1.1 volts. and 0.02 amps.
That's a typical box too, the size that you could install?
Well, that's a lab-based supply, but that was about the size of my hand. So they go into a box that's 300 by 200 millimeters by about 180. So that's size. Okay.
So we've got the first R1. We have a
Keep
shift
polarizing by minus 862.
minus
Minus
860.
862.
It's 957 now.
It's changing already.
It keeps getting more negative.
965, 966. It's changing because it's polarizing.
Climbing,
so
yeah.
I see.
The numbers very negative. But that's close to the feed wire, so you're going to get the most polarization.
So now we've got on
Minus 900.
900 and on R2. Location R3 is minus 797. And
That
R4
last point was outside the zone of where we've got the anode, so that demonstrates it's throwing power down there.
is minus 798.
So despite the anode being here, although it's going to be a contribution from this knife, because we've just installed it.
So our feed
Coming
points
right
on this facade, the current's flowing through the grout,
All your wiring has to
all the way around to this side,
central.
and even polarising this side without any feed wire actually embedded.
So there's no wire on this face over
It
here.
is purely
and
the
that
material.
Where's R4? Is that where
At
that's
this
at?
point, yeah.
Okay. All right. So then it's traveling through,
Round mortar, yeah.
even though it's not even cured yet.
Yep, conductive mortar.
Which range tells us that we're experiencing rust?
These are all very low.
Okay.
By the nature of the new mock-up, there isn't any corrosion really happening. The fact that we can shift it in a negative direction proves that we can pass current. What we can actually do now is prove that we have controllability, up the voltage, and we should see more negative results again. So we'll give that a quick try.
There is battery backup on it. It went down straight away. It sounded data for a while, but it's screwed back to positive.
So we've turned it up to 2 volts and 0.03 amps. We'll go through the testing process again.
Okay.
So now we have minus 2045 at R1. R2 is minus 1500. R3 is minus 255, which is outside the area of protection. There is no anode material installed that low. And R4 is minus 1369. So that shows we have controllability over the anode. We introduce more current and get greater shifts.
Okay. So then, when you up the voltage, you up the amperage. Why the drop in the negative number for R3?
I'll just check that.
I must admit, I was surprised to see it at 700 volts.
It is. It's just
But if you compare that number with the base number, it's still
still
polarized.
shifting. It may have been.
I don't know why it started at 700 volts.
Okay. That was just an odd reading.
It may have been. Yeah.
Because the others, you had decreased. You went from 960 down to 2045 for R1, but for some reason the R3 is the only one that went up.
It's actually outside the area of influence, so it may be shorting back somehow.
Just not part of the system.
So we have controllability over the areas we've installed the anode. It polarises the correct way. We could do another polarisation, 3 volts.
I say go further. Really, we wouldn't go any further than that. Minus 2 volts of our polarization is way over what we would need in any event. So it would never be operating on if we can actually.
What would be typical for the voltage and amperage? This first one?
We want to see roughly about 300-400 millivolts shift. But bear in mind what I mentioned about these being as founds, we need to interrupt that process to get the instant off on the real polarization value. So we want to see several hundred touching back overall, giving us about 300 or 400 millivolts shift. And that's the optimum.
Stabilized. See the data?
Yeah, I was checking out what you're doing.
Okay.
Is it off now?
No, it's not off yet.
If we switch it off now and do another set after a couple of minutes, then you'll see it going back to
Depolarization.
back to where it was. Okay. Roughly, it will take a little bit of time to discharge, so the numbers may vary slightly.
It's just a moistened sponge then?
Yeah.
That's
help
all
it.
that is.
Yeah, it's over the top of the sensor head. That's a silver chloride reference electrode at the end of that line. That's what we actually use for intrusive half cell sensing that I mentioned in the presentation. So we're just using it as a surface of this.
Is there a limit to how big of a building you can do? I mean, you can do a high-rise with one system, or would you need multiple systems for larger structures?
Well, it's where you place the anode. So there's no limit to the size of the structure you can do, but it just increases the number of zones that you're installing. And that's why we've gone for a network management system, so you're not bringing big bundles of cables from every zone and trying to centralize, because you end up with a weave of electrical cables. So we keep those wires local, and then let the network run to the next zone to keep the wiring limited.
It's literally a copy and paste across the structure.
How many wires would make up a zone?
Well, in the zone you'll be bringing 8 wires back. So we run the anode and the cathode as 2 separate ring mains. So you've got 2 cables coming back, 4 points in a ring main, 2 coming back, 2 coming back from the cathode, and then you've got 4 monitoring points coming back. So there's 8 cables coming back to the box. And then you run the AC, the DC and the comms networks between boxes.
Usually all those cables will fit within maybe 1.25 inch conduit, so it's not massive. If you use trunking, maybe 1 inch by 1/2 inch trunking, it'll all sit nicely into that.
That all then comes back to what we call a network access unit, which is our communication route on and off site. So it will control the network what we tell it to do. So it brings the data back to a central point in the data logger. It's scheduled to operate for the period. So we take that testing data and then we communicate with it to offload that data back to site, back from site, back to the server. And then we have a look at it, and if we need to control it, then send a signal back to the network access unit to the zone we want control. And then we'll up or down the current, score the data back to tell us what it is.
So if we take some off potentials now.
Yep, so if you go there,
So the voltage and the current are both 0.
Okay.
The value for R1 is -199. R2 -141. R3 is -11.
Base was 10. Was 10.
going between the negative to the positive.
Positive.
So it's actually a very low.
It's -22, which is less than base. This is strange. Yeah, perhaps. There's something going on.
So that's not typical?
Usually we wouldn't go below base. It's
Okay, not that dramatic.
no. We'll have controllability on the side that we've got the anode installed, everything.
You also bear in mind it would normally be embedded sensors and not a handheld.
Not a
on
handheld,
the brick trying
yeah.
to get a good connection.
Gotcha.
So it's not exactly the same point we put the sensor back on,
Right.
even though I'm trying to.
Did you
your sensor down the line? Could be a solar flare.
Well, the oldest one is 25 years. So we were asked by our highways people, transportation people, to always provide some for this year.
Yeah, that's fine. Is there any questions you'd like to ask regarding the installation?
Yeah, are most of the guys electricians that do it? No? So it's that unique where you don't really have to have any knowledge of electricity? No.
The guys that I'm working with in London at the moment, they're all stonemasons or bricklayers. It literally is as simple as repointing. Those guys down there are happy doing it. They've got a product that works, and repointing over the top ties in with all the colour match materials that they use down there as well. Very happy with it.
Do you guys do any placement of the electronics, like the boxes? Do you place that all, or is a contractor everything?
We tend to design the locations and with agreement from either the building owner, the architect or the engineer. They know what they want in the building, so we try to put them in discrete locations. They'll be reflected on the drawings, but on site if they have to be moved within the zone, it's okay, because you're anywhere on the network.
I think his question was the actual installation of the boxes themselves.
Do we pin them?
Yeah.
No, contractor does.
Contractor puts
Yeah, and we ask for the cables to come back to that box labelled, and then we turn them.
We get an electrical contractor in so we can meet the codes and requirements of installing the system correctly. We'll go and commission it after that fact.
Because I mean, low voltage, you wouldn't really need any type of specific license for...
The TR units are powered by AC voltage, so it does require an electrician, qualified electrician, to do that side of the electrical installation. The DC side of the circuit is for the measurement boards, which you're quite right, you don't really need any qualifications to deal with that.
Gotcha.
Will this clean off?
Yep.
You try it. Sponge over there.
Even once it's dry?
It's just the normal methods of removing any. You can.
I don't know if it's set up like an epoxy where...
You wet down, damp sponge. If it's slightly more stubborn, you can use a little bit of a wire brush, but it cleans up.
So once it cures out like mortar, can you reconstitute it by using the liquid? Is it possible to make it to a paste-like form again?
No, you would want to do maybe a slurry of it and do that.
Yeah.
Yeah. Okay. You have to have some of the powder associated with it.
Gotcha.
Literally wipe clean after the fact. Would help if I had a clean sponge, but
That may be tough though if you had like so this is a smooth brick, but if you had a textured brick where it gets into the pores, that'd be difficult.
But it is a water clean-off. You just have to be persistent and trying to get in the groove.
but the installation in London is on Portland stone. The guys down there are very diligent in the way that they're injecting the mortar, so they don't really have any overspill. So they mitigate that problem.
Create more work for themselves otherwise.
And that's probably
That's
much as we can show.
It's a very simple installation.
Yeah.
Even I can do it.